Welcome to lecture number 47 of fuzzy sets, logic, and systems and applications. In this lecture, we will be discussing the orthogonality of fuzzy sets. Now, let us discuss another term. Let us understand the orthogonality of fuzzy sets. So if we have a term set Tx, so we have already seen that the Tx includes many linguistic values, and these linguistic values, if these are represented by fuzzy sets, so let's say the term set Tx has multiple linguistic values and which are represented by fuzzy sets T1x, T2x, T3x, and so on, so forth till Tn of x. This means that term set has n number of fuzzy sets. So this means what? This means that if we have any variable, any linguistic variable, and if this linguistic variable is within the universe of discourse, let's say this is the universe of discourse, within this we have multiple fuzzy sets. Means this, the region within the universe of discourse is covered by multiple fuzzy sets. And let's say we have here n fuzzy sets, small n number of fuzzy sets. So here, what is the orthogonality is that if we have a term set Tx and this term set has T1x, T2x, T3x, and so on up to Tnx of a linguistic variable x on the universe of discourse capital X. So this is called the orthogonal if it satisfies the following property. So this means that if we take summation of all these membership values which are there for a particular generic variable value x. So here the summation I is equal to 1 up to small n mu ti of x is equal to 1 for every x belonging into the universe of discourse. So this is very simple to compute. By taking an example, I'll be able to understand you better, I hope. And so the Tix, we can say the ith fuzzy set in the term set, in the complete term set, are the convex and normal fuzzy sets. That is very interesting to know that all these fuzzy sets which are present in the term set must be a convex and normal fuzzy sets. So let us take an example here and understand. So first we take a discrete fuzzy set. And first we take discrete fuzzy sets A, B, and C to understand the orthogonality better. It's very simple. So by taking the example, by going through these examples, 2-3 examples we are taking, we'll be able to understand the orthogonality of fuzzy sets better. So here we are taking 3 fuzzy sets, 3 discrete fuzzy sets, and these 3 fuzzy sets are within the universe of discourse 1, 2, 3, 4, 5. So means from 1 to 5. So now we see we have a fuzzy set, discrete fuzzy set A, 0.2/2 plus 0.1/3 plus 0.2/4 plus 0.3/5. We have another fuzzy set B, which is 0.6/1 plus 0.6/2 plus 0.7/4 plus 0.7/5. The C fuzzy set that we have is 0.4/1 plus 0.2 oblique 2 plus 0.9 oblique 3 plus 0.1 oblique 4. So this way we have the three fuzzy sets, and now let's check whether the fuzzy sets, the orthogonality condition is satisfied for these fuzzy sets or not, for the term set or not. So basically the orthogonality, when we talk of orthogonality, it's for the whole term set. So we simply check for a particular generic variable value. If we sum all the membership values, if it is equal to 1, we say and it should be there for all the generic variable values. Means throughout all the generic variable values, at any generic variable value, we should have the summation of the membership values is equal to 1. So this is the condition. So let us now quickly check. So since we have the three discrete fuzzy sets, and if we take a particular generic variable, let's say x is equal to 1. So see here that if we take the generic variable 1, the summation here is going to give us the 1, the membership value 1. So we can say that at generic variable generic variable value 1, the summation, the total of the membership values of all the coming from all the fuzzy sets is equal to 1. So this way we can say that this is 1. For corresponding to generic variable value 1, we are getting the total of the membership values is equal to 1. Similarly, now we check for the other. So here we can write it like this, and similarly here also we see that summation of membership values for all the three fuzzy sets. So this is also equal to 1. Similarly, we see that this is for 2. This is for the generic variable value 2. Here we see for generic variable value 3, if we sum all the membership values. So this is for 3. So I is equal to 1 to 3. All the three membership values corresponding to the three fuzzy sets, if we are adding, we are getting here 1. Similarly, here for this also, for the generic variable value 4, when we sum this, we see that I is equal to 1 to 3 mu, this I can write here I. So mu I, and now if I write the mu I of 4, this again you see 0.2, 0.7 and 0.1 both are going to give us 1. Similarly, here also the summation of the I is equal to I 1, 2, 3 and then mu I of 5. This is again is going to give us 1. So we see that for all the generic variable values in the universe of discourse, we are getting the summation of all the membership values in the corresponding fuzzy sets in the term set is equal to 1. So this way we can say for these three fuzzy sets, these three discrete fuzzy sets, the orthogonality condition holds for the term set containing A, B and C. So this way we can say that all the three discrete fuzzy sets are basically helping the term set to be the orthogonal. Now you can see the solution in more detail here. On the same lines it has been explained, and we can have one more example here. So we are assuming that we have a term set. We have a term set Tx, which is nothing but which has A, B and C. So we assume that this term set Tx is orthogonal. So here we assume that this term set, so here we are assuming, so assuming that term set Tx, which has the linguistic values A, B, C, and A, B, C are nothing but the fuzzy sets. So out of these A, B, C, two fuzzy sets A and B are, which is again in the universe of discourse here as mentioned, 1 to 6, and these A and B are known to us. Now the question is, if the term set Tx is orthogonal, then what is C? What is the fuzzy set C? So it's very simple. We apply the same condition here for orthogonality, and since we already know that we have two fuzzy sets A and B, and all of the membership values corresponding to generic variable values which are known, now we can have a fuzzy set C, and since it is already said that the term set is orthogonal, so we can quickly manage to find the third fuzzy set applying this condition, the mu Ti of x and the summation I is equal to 1 to n. So here we have three fuzzy sets, so n is equal to 3 here, A, B and C. So let us now quickly go through. We have this fuzzy set, these three fuzzy sets. I can again write Tx is nothing but this A, B, C. So these three fuzzy sets we have, and A is known, B is known. So C can be known by having 1 minus these membership values for the corresponding membership, for the corresponding generic variable value. So we can assume here the C is going to be the mu C of x oblique 1, and then we can have similarly the mu C, we can write like this, let's say C. So C can be mu C of 1, and then we can have mu C 2 oblique 2, then we can have mu C 3 oblique 3, then we can have mu C 4 oblique 4. Then we can have mu C5 oblique 5. Then we can have mu C 6 oblique 6. So now here we can compute all these respective membership values, mu C of 1, mu C2, mu C3, mu C4, mu C of 5, mu C of 6, and this way we can represent it like C is equal to summation over the universe of discourse mu C of x oblique x. So this can be written like this here, and when we use the condition, this condition here, we can find the C is equal to 0.9 oblique 1 plus 0.4 oblique 2 plus 0 oblique 3 plus 0.2 oblique 4 plus 0.3 oblique 5 plus 0 oblique 6. So the condition here is that the sum of all the values of memberships corresponding to the generic variable 1 here. So for 1, for 2, for 3, for 4, for 5, for 6, all the generic variable values, the corresponding membership values are known now, and when you sum these values, so at any point of the generic variable value, the summation of the membership values are 1. So this way, given the condition that a term set X, which is comprising of capital A, capital B and capital C fuzzy sets or the linguistic values, and if A and B are given, C can be computed if Tx is orthogonal. So it's very simple, and the solution is here. You can further extend it. So now we have another example here. We have so before this, let me just quickly go through this and see that with the orthogonality we are getting the C very easily. Okay, so let us now take the continuous fuzzy sets, means a term set which has multiple continuous fuzzy sets. So here the same formula applies, means at any point of time or any point of generic variable value, the summation of membership values given the universe of discourse or within the universe of discourse is going to be 1. So we can clearly see that if we have a term set, let's say T of age, and this term set has 3 linguistic values which are young, middle-aged and old, and these 3 linguistic values are represented by or characterized by fuzzy sets. So if we have this as young and this as middle-aged and this as the old, so we have 3 fuzzy sets. So now we see within the universe of discourse 0 to 90, which is given, within this at any point of the generic variable, we see that when we sum the membership value corresponding to a particular membership value, we get its summation always 1. So the young fuzzy set has the trapezoidal membership function, and middle-aged also has the membership function trapezoidal, and for old also we have trapezoidal as the membership function. But young and old are open trapezoidal, means left open. Young has left open trapezoidal, old is right open trapezoidal. So this way, when we see that we at any point of time, so if we, let's say, if we draw a line here, and let's say here for x is equal to, let's say, 43. So for 43 we see that we have the membership value. So let's say mu for 43, I'm just writing here, for x is equal to 43, the mu young 43 is 0. Mu middle aged 43 is 1. You can see here the membership value corresponding to x is equal to 43. And then we have mu old, this is mu old of 43. Mu old of 43 is equal to 0. So now when we sum this for x is equal to 43, we see that we are getting all mu's for 43. Let's say this is 1, 2, 3. So this is here, and then we are getting 1. So likewise, if we move this line throughout within the universe of discourse, we are getting at each and every place the summation of all the membership values unity. So this way, here you can see every place we are getting the summation of its membership values 1. Similarly, if we take this value, which is x is equal to 30, the generic variable value is equal to 30. So we see that for generic variable value, that is x is equal to 30, what is happening? So what is happening here is that mu young of 30 is, you see here, just look at the membership function characterizing the fuzzy set young, which is represented by the red color. So which is represented by the yellow color. This is blue color. So this is characterized by, this is represented by this mu. This is the fuzzy set young. So this is represented by blue color. So if we look at this, at x is equal to 30, we are getting its membership value 0.5. Similarly, now, so at x is equal to 30 as the membership, as the generic variable value, we see that we are coming across two membership functions. So first is the young, and the second one is middle aged. So we see that, which is represented by red color, and then when we see that mu of middle aged, and if at 30, we are getting this also as 0.5. So no other membership is available here for x is equal to 30. So we can write here mu of old, so this is for 30, or at 30, this is at 30, 0. So when we sum these three, when we take the summation of this mu, all mu's add 30, I is equal to 1 to I is equal to 1 to 3, we see that this is 1. So similarly, for these terms, for this term set having the fuzzy sets young, middle-aged, old, we see that within the universe of discourse, no matter what value you take for x as the generic variable value, for each and every value of x, we are getting the summation of its corresponding membership values 1. And this way we can say the term set here given is the orthogonal term set. So orthogonality condition for this term set is satisfied. Similarly, here if we take x is equal to 60, so for this also we see that we are coming across two membership functions for two membership functions of middle-aged and old respectively. So we see that both of these we have 0.5 as the membership values, and when we see that for x is equal to 60, when we sum these sum all the membership values, we find 0.5 for middle-aged and 0.5 for old, and the summation is 1. And please understand that at x is equal to 60, mu young is 0. I can write here mu young 60, mu middle-aged 60, and then mu old 60. So this is going to give us the summation 1. So this way we can say that the sum of the membership values for linguistic values young, middle-aged and old are 1 for every generic variable value belonging into the universe of discourse capital X, and therefore the term set which is for age is orthogonal. So that's how we test the orthogonality of a term set. Now at this point we'll stop, and in the next lecture we'll discuss the fuzzy rules and fuzzy reasoning. Thank you very much.